afternoon, class. I am not feeling my best. I've had a bit of a sore throat, so I'm going to try to give you guys some distance while I talk today, and when I can't give you distance, I'm going to walk around with my mask on. I lectured all last night to my OChem 2 class with my mask on, and either my glasses fogged up and I couldn't see anything, or I held my glasses up and I couldn't see anything. So this is just a lot easier for me. I also am a bit delirious, I think, from being sick. So I apologize for how chaotic today is just going to feel. We're going to push through, though. All semester, we're going to push through. I want to draw your guys' attention to our Canvas page. I want to talk to you today about what to expect this semester. What assignments you're going to have, what expectations I would like, or classroom expectations that I'd like to discuss with you guys. And then we're also going to have a short little talk about the foundation of science, kind of a mind frame that I would like each of you to have as we go into this semester together. An analogy that I'm going to keep coming back to all semester long because I find it to be the best analogy for understanding chemistry. So first things first, let's look at Canvas. How many of you have had a chance to explore the Canvas site a little bit already? Okay, good number of you. This is our landing page. This reaction that you'll see as kind of the cover photo for the class, we're going to talk about that later in the semester. We're going to come back to it. More than likely, it'll be the last thing that we talk about, but you're going to be looking at it all semester, and you're going to understand it by the time we get to the end. You're going to understand everything about it. These are some of the most useful links that I want you to have access to, quick access to throughout the semester. First things first, our unit modules. This semester, we're going to be doing an assignment series analyzing an organic compound. Your first assignment for that is due next week before we come into class on Wednesday. Each of the assignments is only worth 1 point. Cumulative, the 5 assignments are worth 5 points, and I'll explain how that adds into your grade later on. But this is a mastery-based assignment. I will not give you a 1 until you have mastered that portion of the assignment. I will keep giving you a 0 and feedback on what I want to see on the next submission. The reason I'm doing that is because I can throw molecules at you all semester long. I really can. But I want you to find a molecule that's interesting to you. Ideally, it has something to do with your career. You're all in this class for a reason, so there's probably a molecule that relates back to that reason, and I'd love for this molecule to have some significance to you. So that series of assignments is here. At the end of the semester, there may be an additional assignment. We'll talk about that as we get closer. In each of the units, you will find section breakdowns. These more or less correspond to chapters in our textbook. And I want to talk to you a little bit more about the textbook in a little bit. You'll have a pre-reading quiz, which is your participation for the class. Makes up about 10% of your grade. Unlimited attempts. You never see the right answer, but you can keep going until you get it right. I call them pre-reading because I want you to do the reading before class and then get quizzed on it. What I'm hoping for is that you come into class with questions and then leave class with answers based on the lecture. So this quiz is meant to help build those questions in your mind. These lecture slides, I'm actually not going to use that often. I know some of you are used to chemistry professors that just have slides on the board and that's it, and then they talk at you. I'm going to be doing more board work and less lecture work or slide work. There is a good balance between the two, and I think that I am not at the good balance. I'm a little bit closer to too much board work. But in my opinion, I'd rather go at the pace that it takes to put everything on the board than try to skip over things by just looking at a PowerPoint slide. So you'll have to bear with me on that. Then these section assignments, they correspond to your homework, and we'll talk more about where to find your homework and how to submit them. So section 1, section 2, those make up unit 1. Then you'll have a unit 1 test. We'll talk more about why you've got part A and part B. Unit tests are available on Canvas. They're not taken in class. They're taken at your pace, on your time. There is a window to take them in, though. They open on a specific day. They close on a specific day. If you have issues with that schedule, you just have to communicate with me so that I can open the due dates, change the... Usually I'm open to starting it early, but we've got a pace to keep this semester, so I'd like not to extend them unless necessary. Always open to that discussion. Also on this modules page, you will find a module for midterm information. One thing that I need to do is update the midterm study guide. I looked at it and it said section 1, hybridization and bonding, and the rest of the document was blank. That's very helpful. That's not going to be the only thing on your midterm. So I don't have a midterm guide for you right now. I'm going to try to make one for you. It's not going to be like pretty. It's just going to be a list of things that we covered. But one thing that will help you prepare for your midterm and your final are my summer midterm and finals. I don't want you guys to open the midterm exam and be surprised about what it looks like and what's on there. So I'm giving you an opportunity to look at the midterm beforehand so that you get an idea for what it feels like. You can test yourself on it. You can look at the answer key and score yourself to see what you need to study up on and what you're solid on. Okay. Honestly, the unit modules, they're not super necessary. You're not going to need them a lot because you're going to see in your coming up sections things that you will need to do anyways, and you can just click on them right from there. The only thing that might be useful are the final and midterm exam practices. If you take this link to Active Chemistry, this is our homework platform. This link only brings you to the module where you will need to click to this, which brings you to a page that has a button that lets you load to Active. How many of you took Real Chem here at Slick? Yeah, I know. You might remember that you can't bookmark, thank you. It's a star up there, trust me. You can't bookmark Real Chem and get to it directly, but you can bookmark Active. So once you log in and register, you can bookmark this page and just use it as a quick link on your Google bar. That's what I do. Sorry, you can see I've got a number of classes here. My frame looks a little bit different than your frame, but Active is the only thing that you will need to buy for this class. You do not need to buy a textbook, but you do need to buy Active. Active makes up about a quarter of your grade, or maybe 20%. I'll need to check on that again. A good portion, which means you can't get an A in the class unless you are doing Active. I used to build all of my own homework, and I would grade all of that homework. And I had too many students and not enough time to actually give feedback on that homework. And I had two options: grade by completion and not actually tell you if you did things accurately or not, or utilize a resource that will give you feedback so that you know whether you're doing things or not. And I would rather you get feedback and actually understand the topics and know that you're getting them right or wrong than just grade you by completion. So This is my way of doing that. This frees me up to give you more targeted feedback on higher stakes assignments that allow you to better yourself for the midterm and the final. On Active, there are homework problems, but there are also practice problems. I had students actually give me some feedback that said there are too many practice problems. You'll notice for some of these, there are over 100 problems for you to do. So I don't want you to do all of them, just the ones that are relevant to the things you're struggling with. Hybridization, go find the ones on hybridization. Acidity, go find the ones on acidity. So, some of the other things on here. This class recordings page. This is our first class, so I need to update this. This is still the summer recordings. I've got my camera up here in the front, trying to capture the whole board. The quality is all right, but it's not amazing. The thing is, this is not an online class. It is an in-person class. So this is me trying to help you out in case you miss class. You can catch up on the notes. I can't guarantee these recordings. I can't guarantee that my phone isn't going to fail, that my laptop won't fail, that the recording won't fail. But this summer, I was able to record all of my lectures for OChem 1, and I uploaded them to a YouTube channel. And on YouTube, you can zoom in better, you can pause, change the speed better, a little bit better quality, and it has auto captions on it. So if you want to utilize videos and you're not happy with the ones that are happening here, or I failed to get one recorded for our class, you can find my YouTube channel and just find the content that we covered, and you can find very similar notes there. I will say my notes change semester to semester. It's just kind of what comes out. They're all very similar, but the examples are going to be different than what you see this semester. Sometimes that's nice. You can get two different references for what you're trying to learn. So that's an important link. I want you to know how to find those recordings. If you ever need to meet with me on Zoom, this is the one and only Zoom link I ever use. And then I want to talk to you about these files here. We're going to have a big segment of our class that talks about instrumentation. This is a document that I've created that helps analyze all of the molecules that we're going to learn about. I'm going to give you versions of these tables on your midterm and your final exam. So I'm going to be pulling these up and using them in class to get you familiar with them. A tool is only as useful as you know how to use it. So I do want you to recognize there are some small changes to these documents that actually appear on the midterm and final. So when you need to know how to use the tool, I want you to know how to use that version. But this is more detailed, better for you in your studying and your learning. Underneath that, I've got this document. 2 years ago, I had a brilliant OChem 1 student aced my class, came into my OChem 2 class, and at the end of OChem 1, he said, if there was one thing I could have, it was a table of functional groups, so I could see all the different things that we're going to need to know. And I said, that sounds really hard. I'm on it. So I made this. It's not perfect, but it's pretty filled out. We're actually going to be utilizing this in one of our chapters this semester as well. So you're going to get to know this. You know what? This isn't the updated version, which really surprises me because I updated it over the summer, so I don't know why it's not there. I'm going to update this. If you are someone that prints out everything for the semester, just keep in mind you might want to reprint this later. Okay. You guys will have a syllabus quiz due at the end of the week. Very easy, unlimited attempts, I believe. I want you to get all of the points for it. But it's just to make sure that you understand all of the key parts of the class. You're also going to need to get your active set up. And I want you guys to be familiar with the STEM Center. How many of you have been to the STEM Center before? Really? How many of you are new to SLIC this semester? Okay, that explains a few of the hands. The STEM Center is our tutoring center, free for all students. You just need to sign in with your S number. So if you have your one card handy, or if you can pull it up on your phone, you'll need to log in, but that is the smallest barrier. It's a free resource for tutoring help. I have 2 students. I need to update their times on here, Johnny Pope and Sagan Wilkinson. They took my OCHIM 2 class in the spring, so they know the way I teach. They know what to expect. They have copies of my old exams to help you study with. I'm going to put their schedules on here so that you can go to them for OCHIM help. I want to encourage you not just to go to the STEM Center for tutoring help. Don't just go to the STEM Center when you have questions. Go to the STEM Center at a scheduled time every week. Use it as a place to study, because while you're studying, while you're doing your homework, that's when the questions come up. I have had a number of students that take this night class, and then they go down and spend 2 hours in the tutoring center until they close at 9 o'clock. And Johnny, I know for a fact, is there most days of the week until 9 p.m. So he'll be there to be able to help you answer questions on OCHIM. And he is one of the best tutors that we have down there for OCHIM, for sure. As you keep scrolling down, you're going to notice this document that auto opens. That is intentional. I don't want you to ever guess about how to open that schedule. This is our course calendar, and we're going to do our best to stick to it as much as possible. I have been developing my calendar over the last few semesters, and I feel like I'm finally getting the rhythm down of how to stay on pace. But this is not a contract. This is a prediction. These dates are flexible, and they might change if things come up and we have to move them. You'll see in purple are our lecture meetings. We're missing a couple of days these first couple of weeks because of convocation and the holiday. In blue is our first unit test. You'll notice that that spans Thursday and Friday. So if you work weekends, you can try to fit it into your week before the weekend. But if you've got an incredibly busy work week and you have the weekends off, you can do it on Saturday and Sunday. Plan ahead. I'm giving you the idea of when those are going to be available to you. So look ahead in your calendar and try to plan those in. Talk to me if you've got reasons that they're not going to work. You'll notice that your first unit test is due 2 days before the last day to drop the class. I want you to experience a major assignment in this course before you decide whether you want to keep this course on your transcript or not. And I hope that you all keep this course on your transcript. But I know that some of you are rocking the fence right now. You're not sure if you need it. You're not sure if you should push it off. You've got 1,001 credits, plus you're working 50 hours, and you're taking care of a family. So maybe this class doesn't make sense right now, and I want you to know what to expect throughout the semester. So we're going to do our best to finish up Unit 1 before we get to that drop deadline so that you can make an informed decision about staying in the class. We're not losing any day to fall break, but I will say your third unit test will still be open over fall break. I know that we're not losing any time, but hopefully your schedule frees up more, and I think that should make it easier for you to do that third unit test. But again, I'm giving you this in advance so that you know to try and plan for it. I want you to notice that after fall break, after the third unit test, we've got a day before our midterm. We're not covering new content on that day. We'll be reviewing for the midterm. I have prepared a lot of material for you to study for the midterm, which means I'm not going to prepare anything for that day. I want it to be your questions. I want to target the topics that you need help with before we get into the midterm. After the midterm, we're moving into Unit 4 and Unit 5. Unit 5, we lose a day to Thanksgiving break. And then we've got 2 lecture periods after Unit 5 before our final exam. And we'll use those 2 lecture periods to review for the final. Now, like I said, maybe things go drastically awry and I need to reclaim those days to cover material. But I would rather give you those days to prepare for the midterm, or for the final, to ask questions, to clear up confusion, to master your concepts, to ace the final. Does that sound good to you guys? It does mean I'm taking a few days out of our time that I could have spent slowing down the material, but I think you'd also still agree it'd be better to just have that extra time to ask questions and review. Our final exam is set by the college. It's on Monday, December 15th. You'll notice that it's not at our usual class time. Our class meets at 5 o'clock, and our final exam starts at 5:50 and runs to 7:50. We'll meet in this room. The midterm, on the other hand, is not set by the college. We're going to meet at 5 o'clock in this classroom. You will not have to go to the testing center for any tests for my class. In my opinion, you signed up for an in-person class. That means you've dedicated this time to this class, and I need to make sure that I give my assessments during this time. So, other than the final exam, which I can't control, the unit tests are kind of at your pace over a 4-day period, and the midterm is on my time. We use up class period for it.
Are the unit tests taken online then?
On Canvas.
Okay.
Do you think I require a lockdown browser for it? Raise your hand if you think I require a lockdown browser for the unit test. I don't.
Cool, thank you.
What's the point of lockdown browser? What? Really? How does it prevent cheating? Because it sees you looking around? Because when you're taking an organic chemistry test, you're not going to be like solving a problem on a piece of paper and looking around. Or because it listens and you can't just like read the question out loud and then somebody in the other room holds up the answer. Does it prevent cheating? I don't think so. I think it's a form of prohibition. And I don't think prohibition got anything anywhere. So I encourage your notes on the test. Because unit tests are a mid-stake assignment. Homework is low stake. Exams are high stakes. Exams are a lot of your grade and not a lot of opportunity. Unit tests are a good part of your grade, but a few opportunities. And the homework is not a lot of your grade and a lot of opportunity. So on those mid-stakes assessment, I want you to have support and struggle. Homework, you have support and tons of freedom. No strict due dates, no late points, no time crunch. All of your homework, all of the internet at your fingertips. On the unit test, I want you to just use your notes. I want you to know that your notes are going to help prepare you for the midterm and for the final. And I want you to know how quickly you can answer those questions. I want you to feel under the gun a little bit. Because when you come in for the midterm and the final, you're going to have a much shorter amount of time to answer the same amount, more questions, challenging environment. So it is meant to build you up. I don't think the lockdown browser helps you do that. I'll talk a little bit more about the unit tests later. I don't want to spoil too much of it right now, but no lockdown browser for it because I don't get it. Truth be told, I never had to use lockdown browser, but I was right there at the cusp of it. I was in grad school during the lockdown. And so we hadn't figured out the lockdown browser that semester. We had to proctor students while they took their exams. And I got proctored while I took my exams. And then I left and I never had to use lockdown browser. And I don't like it. I don't like the sounds of it. I never have. I only use it for Gen Chem because I'm forced to. But what can I do? All right. Any questions on the calendar? Got this nice block of text that I really expect all of you to read in depth. I'll be honest, I haven't read that in a while. It's probably just the spiel I'm giving right now. But underneath it, I've got this external resources material. Earlier, I mentioned the textbook is not required for purchase. In fact, I need to add a link here. LibreText is a website that has a lot of different organic chemistry textbooks, totally for free. The one that I think is very helpful is this McMurray textbook. This is a 10th edition textbook. 9 editions that were sold by publishers, and now this edition that this author decided to make open education resource. So it's vetted, it's well made, it has the answers to all the questions you might have. All textbooks, in my opinion, are more or less the same. But some other resources. If you like watching TikToks or YouTube shorts of people doing chemistry problems, Community is a social media-based chemistry learning platform. They came across my TikTok this summer, and I thought I'd share it with you guys. They do have some like paywall stuff, but they have a lot of other videos that are just out there. We're going to use some of these websites throughout the semester. And one other link that I'm going to add here is the link to my YouTube channel, so that if you want to use the YouTube videos in place of the videos on Canvas, you can find it there. It's not a required link. It's a resource that I think is valuable. Any questions so far?
So for the reading you mentioned earlier, for the little pre-quiz or whatever, are we supposed to be doing the reading in that McMurray textbook? Or?
You know what? I'll be honest. I don't even care if you do the reading. You could go through that quiz and try to answer them. You could copy and paste those questions into Google and see what sources come up answering it. You could go to this McMurray text. You could go to the Carey text. I think that just about any textbook is going to help you answer the questions that are in that reading. That reading is meant to spark the right questions in your mind so that you get confused. I don't want you to feel totally confident on the answers by the time you're done with it. I want you to know what to expect when you come into class, what you expect to learn when you come into class. Does that make sense? Okay, truth be told, the section pre-readings do line up really well with the McMurray text, although it's not our official course text. They don't align super well with the Carey text, which is our official text. I don't get to choose the official text, our course lead does. But the course lead doesn't even require the edition that's in print. He encourages his students to buy out-of-print editions. So he's got his own system, just doesn't allow me to have my own system. So for instance, Unit 1 is 2 sections that line up pretty closely with chapters 1 and 2 in this free textbook, but make up chapter 1 in our official textbook. So you may need to just pay attention to where that material is being covered in like the table of contents for whatever edition of whatever textbook you look at. Does that make sense? Cool. Pre-reading quizzes are not meant to be hard. I'm not a big believer though. I'm not a believer in buying a $300 textbook. Not for organic chemistry. Not when there are dozens of free resources out there that are just as good as any of those other newest edition prints. All right. No questions.
Can we purchase the active stuff through that link, or is that like paid for by like our tuition fee?
Oh, good question.
Like a buy-in?
I think that you have already paid for it in your tuition. Yep. You know, I keep forgetting about that. So my first semester using Active, I got on the ball a little late, and they couldn't embed it into your course fee. But I do think Because I keep getting this from students where they're like, I never had to pay. And I'm like, huh, maybe it's free now forever. I think you bought it already when you registered for the course. Do you have a guess at how much it was? I think it was like 40, yeah. Or maybe 49 with the bookstore's markup. Yeah, so not the biggest fee, definitely cheaper than a textbook. The course leads section, although he tells students get whatever edition you want, he assigns homework problems out of it, so you have to get some edition. And he grades his homework by completion, not by accuracy. So you just want to turn in the right answers. And so a lot of students spend hundreds of dollars on the solutions manual just so that they can get the right answers. But luckily, I don't grade by completion. I don't grade at all. It grades for me, and it grades by accuracy, so you know whether you're getting it right or not. I have sat with students in the STEM Center who are just copying problems out of that solutions manual, and they're copying the answers wrong. Like, I'll watch them draw the wrong molecule, and I'm like, oh, you're not getting anything out of this. It's literally worse than copy-paste. So I think $50 for active is going to do you better than $300 on a textbook and solutions manual. I hope you guys see that. All right. I would like to spend about 5 minutes having you guys get to know each other. Maybe the people at your table, maybe move around to get to know some people at a nearby table. Introduce yourselves, and then head over to Simple Syllabus. If any of you have your tablet or your laptop or your phone, open up Simple Syllabus, and I'd like you to find 3 things. Imagine that you have a friend who didn't come to class today. I want you to find 3 things. The most important things, things that are surprising, things that are confusing, and I want to hear those from you. So as a group, can you decide on 3 things? In the meantime, I'm going to be handing out little slips of paper that help me get to know you. I'm going to put on the board what I want you to put on them. Don't put the 3 things to know on there, because that slip is for me with your information. So get to know each other. Let's talk for a few minutes, and then I'll round us back up. But yeah, we won't cover that. Because that's something I want to do. Well, it's a good point. Like, it's not on here. That's a good feeling. How was that?
Hi. I work in a big hospital. I get to float, so I do float. But he trained me.
You know what? I grew up eating those salads in a bag. Yeah, just with ranch on top. All right, are we ready? Can I hear from you things that you thought were important, confusing, or surprising? Oh, I thought that was a hand. You want one?
Sure. If you miss class, there's video recordings.
Good. So let's talk about attendance. I don't require attendance. I do believe that you are all adults and that you know the learning style that is best for you and what is best for your schedule. I've heard a lot of professors say that you have to require attendance, especially for a challenging course like OCHEM, where they're just not going to get the material and they're not going to do well. Last fall, I watched 2 OCHEM 2 students taking OCHEM 2 for the first time show up on the first day, the midterm, and the final, and they were my highest scorers in the class. I also watched 3 students show up every single day, and they were some of the lowest scorers in the class. You cannot say that attendance equals a good grade. It's all about what you're willing to put into the class. And I will admit, those same students that didn't do so well, they worked hard in the class. I think that they did better than they maybe would have anywhere else. I think that they already exceeded their own expectations, but they did have to work really hard and they didn't see the fruit of that labor the way that they expected to. So I don't require attendance because I don't think that is going to make or break your grade. So in the event that you don't want to come, or in the event that you do want to come and something comes up and you can't, I've got these video recordings. Hopefully hopefully I will be able to get them all from this semester. But like I said, you'll have access to my YouTube channel that has the summer recordings as well. So worst comes to worst, you can always just go there for that. Yeah?
I'm Maisie. One thing that I looked before class, and the simple syllabus is different from that big long paragraph on the home page. And the grading scale is laid out pretty well, but there's also stuff in that home page that says that we can have a page of notes and that the final can replace your grade completely with that grade final.
So I will
what is
admit,
that?
I'm learning how to use simple syllabus every semester. When it was forced on us, I used to have such a good syllabus that I made on Word, and then I couldn't use it. I had to use simple syllabus. So I'm learning how to use it better. And like I said, I haven't read that paragraph in a while. I think I used to have that act as my syllabus. So I need to go in and make those changes now that I know how to use it better. But I'm glad you brought that up. So one thing that Maisie mentioned is in that paragraph, but not in the syllabus, is my cheat sheet. I will allow you guys to bring one side of a sheet of notes for the midterm and two sides, front and back, for the final. And I do not keep these. I consider them to be your most valuable study guide. This is not an advantage. I want to make that extremely clear. This is the biggest risk that I can put over your heads. Because some of you are going to think, the night before the midterm, I'll make my cheat sheet, I'm going to ace the exam, and you will score the lowest. Some of you are going to start building your cheat sheet after the first unit test, you'll revise it after the second unit test, and you'll revise it again the night before the midterm, and you won't even look at your cheat sheet, and you will have the highest score. And that is the goal of the cheat sheet. Know it so well that you don't need it. If you don't know it at all, it's not going to do you any good. So, I cannot stress this enough. This is a risk. The best way to survive this is to revise, revise, revise. I do think that if you keep it, though, you will have the cliff notes of all of the toughest stuff in OChem 1. One of the reasons that I split how much you can have between the midterm and the final is because the midterm is shorter than the final. The final is cumulative. And so if you are happy with your midterm cheat sheet, you can just flip it around and add new material from the second half of the semester. Although I've had students that get very creative with how they come up with two sides. Some students would rather have two sheets, both the front, so it's not bleeding through or anything like that. One student asked me, can I bring this number of index cards because I did the math and the surface area is all the same. Have at it. That helped him combine material from each section so that he knew where to look for each thing without having it all lost on this big sheet of paper. What size sheet of paper? We're going for printer paper. Somebody correct me if I'm wrong. That's called like type A paper. A4, thank you. Printer paper, A4, it's that 8.5 by 11 or whatever. Notebook paper works pretty much the same. I want to say legal pads are a little bit longer, so that's what I would avoid having that. Now, some of you are going to test at the testing center with accommodations. Most of you are going to test here. The testing center will only allow handwritten notes, which means I need to make this fair. Everybody only gets handwritten notes. Some of you are writing on tablets this semester, and I understand that you would rather write your notes on that tablet and then print them off and keep it within a page. But the testing center wouldn't allow that, so I'm not going to allow that. You'll have to track down some printer paper and a pen or pencil and fill it in. No printing anything onto it, no taping anything onto it, all your handwriting. Okay, any questions on that? And then Maisie had another good point, which is the final exam grade replacement. So, because my final exam is cumulative, I believe that if you score higher on that exam than you had been doing throughout the entire semester, you should get that score for the class. Doesn't matter to me that it was the last second. You showed me on your final assessment that you understood the course material. So, the final exam makes up something like 17%, maybe closer to 19%, because it's part of 35% of the grade with the midterm, but the final is a little bit larger. So I will plug it into your grade, but I'm also going to compare your final grade to your final exam score, and whichever one is higher is the letter grade that you take. Truth be told, most students score on the final exam very similar to what they scored throughout the semester. So few students benefit from it, but I have had a number of students over the semesters that move up a letter grade, or they were close to failing and they secured a letter grade for the semester. So it is useful, and I think my policy is in sound reasoning. You're proving yourself on your final assessment. You'll have a question about that on your syllabus quiz that clarifies it a little bit more. Other things you guys want to talk about?
Problem types on the midterm and final? All choice?
Good question. A lot of organic chemistry classes are one of two ways. Online only organic chemistry is all multiple choice. And a lot of in-person chemistry classes, especially like at the U, other four-year institutions, it's all short answer. I try to have a blend. A lot of you are taking this class because you have a standardized exam to take after this. And so I want you to experience multiple choice questions like a standardized exam. Not all of you are doing that, and to be honest, to be able to do a standardized test, you should be able to show your work anyways. So I want you to show your work to me throughout the semester. So you'll have matching, multiple choice, drawing type questions. And again, take a look at the practice midterm. It's not going to be copy-paste, trust me, but it's going to be very similar. Similar number of questions, similar number of the types of questions, same number of points. Good question. Other things you want to ask about? Other things you want to point out? All right, I want to clarify the unit tests a little bit more. Unit tests come in two flavors. Part A, which is all multiple choice, roughly 10 questions. I think all of them are 10, maybe one of them is not. 10 multiple choice questions. Each of those 10 questions hits a learning objective in our chapter or in our unit. For instance, recognize hybridization, recognize charge, recognize the product of a reaction, X, Y, and Z. Within those learning objectives, I have built a bank of questions. So you will get a question that maybe your classmates don't get. It's unlikely that you will have the exact same quiz as your classmates. I also give you 2 attempts on these. The reason I give you 2 attempts is because I want you to master those questions. I want you to master that learning objective before you see it on the midterm. I want you to take your first attempt and look at what you got wrong and what you got right. Target your studying on what you got wrong. Focus on that. The second time you take it, it's more than likely that you'll get a second question, a different question from that bank. It's possible you'll get the same question. Either way, you will almost be guaranteed a totally different quiz, a unique quiz with a different combination of questions. So, if you struggled on a certain concept, you go for your second attempt, you're probably going to see a different problem, but you'll be able to apply your studying on that second attempt to that new question. That should actually give you more validation than just answering the second, your second choice answer on the original question. You should be able to say, I know I learned that material now because I got asked a different question and I still answered it right. So, 2 attempts, 1 hour each for those attempts. So make sure that you're planning for that. Part B, short answer. 1 attempt, 1 hour. These are between 1 and 3 questions, depending on how challenging those questions are. This is where you have to put pen to paper. Because like I said, on the midterm and on the final, you will be putting pen to paper to draw me things. So I want a chance to give you practice to draw things and a chance for me to give you feedback on what you're drawing. For instance, the Unit 1, Part B, has you drawing a molecule and has you drawing electron arrows. So that on the first unit test, I can say, this is what you're doing right here. This is where you need to focus your studying before it comes back up on the midterm, before it comes back up on the final. 1 attempt at that because it's short answer. I won't have time to grade it and then have you try it again. So a little bit higher stakes there because you get less attempts. Does that make sense? Okay. Indigo?
For the part A having 2 attempts, does it like keep the highest score or average it or?
Keeps the highest. Yep. And I would say most often, probably 3 out of 4 times, the student scores higher on the second attempt. But I do see it happen where a student scores lower on the second attempt, which just says that they didn't understand some of the questions on the first attempt as well as they thought they did. Because when a different question comes out of the bank on the same learning objective, they don't get it right. Either way, it still sets you up to study better for the midterm. It targets your studying. I'm not going to give feedback on Part A because I think that by having 2 attempts and knowing what topics you're doing well on and what you're not doing well on, that helps you know where to study. I'm going to give you lots of feedback on Part B. That's my targeted direct feedback to you. I took a course on education on how to give effective feedback. And I found that too much feedback hurts a student. Too little feedback hurts a student. And there is a happy medium. So I'm trying to find that medium of giving you just the right amount of feedback to keep propelling you in the class. Let's just clarify the textbook. Optional purchase. You know, there's a resource I keep needing to add to my front page for external resources, and that is Klein's Organic Chemistry as a Second Language. Has anyone been recommended that book before? Yeah, I have it right here. There you go. Klein also has a textbook, but Klein's Organic Chemistry as a Second Language is truly a good way to approach organic chemistry. It is truly a different language. You need to treat it as such. So I have a lot of students that use his book and feel like they get a lot out of it. It's not his textbook, but he does have problems in it for you to practice and apply yourself. All right. Anything else you guys want to talk about around the course? I want to talk a little bit about class dynamic then, class expectations. So things that you expect of me, things that I expect of you, things that you expect of each other. I'll say first about grading, especially with unit tests. My expectation is that I'll grade them on the Mondays after they are due, before we come into class. I should have time in my Mondays to grade them, and that's what I'll aim to do. That way we can come into class on Monday and talk about the unit tests that you just wrapped up the night before. Same thing with your messages. I'll try to reply to your messages within 24 hours or on Monday after the weekend. What about expectations in the classroom around technology? What do you think should be allowed? What do you think should not be allowed? What expectations do you have that I would allow? What expectations do you have of your classmates when it comes to technology?
I'm guessing you don't want us on our phones the whole time. I'm
As
assuming
he puts his phone away.
I was using it to look up stuff for signing.
That's what they all say, but so I will say, I don't care if you're on your phone. I do care if it's distracting, not yourself. I assume that's why you're on it. I mind if it's distracting me or if it's distracting your classmates. That means like volume up. I wouldn't want it, right? But like watching things silently. I had a student who had his phone on his desk all semester with one AirPod in, watching basketball all semester long. Couldn't be me, but he wanted to watch. It didn't bother me, and I never heard from his classmates that it was distracting them. Actually, I think he had it sat down too, so no one else could see it. I don't mind. Truth be told, when I took Calc 2, Fridays at 1 o'clock, I'd come in after lunch, and after spending time in the sun with my friends, and I'd sit down in that ice-cold room and listen to my professor talk about integrals. I wanted to sleep so bad. And I cannot stop myself when I need to sleep. So I sat on my phone playing games, and I stayed awake, and I could hear all of the important things that my professor said, and I could take notes when I needed to. And I got an A in Calc 2. So, as someone who benefited from being on his phone in college, I'm not going to limit you guys from being on your phone, so long as you're not distracting your classmates. Anything else you guys have to say on technology? I think maybe it goes a similar direction when you look at all of the people that have their laptops and tablets out ready to take notes. Could you imagine if I was trying to ban that? I honestly don't know how you guys take notes in OCAM on laptops, but one of my strongest students over the summer only took notes on a laptop. So I know you guys can do it. I'm going to allow it. I had a student in my Gen Chem class this morning that said, I don't know, if it's really bright and it's in front of me and it's glaring, I don't know that I'd want it. So one expectation that I'd like to discuss with you guys is communicating with each other. Can we calmly communicate our needs to one another? I know that we're a bunch of strangers, but we do need to be able to live in this space together all semester and get the most out of it. So, if you don't feel comfortable talking to your classmate, come talk to me and I'll mediate. And if your classmate is distracted by something that you're doing, maybe you can find another place in the classroom that won't distract them quite as much. Can we have the expectation that we will support one another's learning environment as best as we can? And that we will have non-heated conversations about improving that learning environment? Cool. What about expectations on food? Dinner time. Not everybody in here has the same schedule. Some people are getting ready to go work a night shift, and other people are coming in from working since 8 a.m. So I'm fine with you guys bringing food into the classroom, so long as I get a bite when I want one. If it is aromatic, it might distract your classmates and make them hungry. So maybe think about how yummy your food smells before you heat it up and bring it in. I had a student in my gym chem class that said you need to be mindful of students that come in here afterwards. So if you make a mess with your food, would you clean it up when you're done before you leave? Leave it better than you found it, right? I think food is kind of a touchy issue in a classroom, but you guys need your brains to work for this class, and your brains need fuel to work. So I want you guys to have that fuel. Speaking of which, going back to that idea of sleeping in the class, I don't mind if you guys sleep either. Like I said, I wasn't trying to disrespect my professor by sleeping in his Calc 2 class. I just really needed to sleep. So if you sleep, I will take it as a badge of honor that you find this a safe place to sleep. It's okay. I can't be offended because I'm getting paid. You can try. Don't try, actually. You'll get in trouble.
Do you hold office hours?
Oh, I'm so glad you said that.
Or is it just like the Zoom meetings?
No, I hold office hours, and I'll show you where it was. I always forget to show this. At the bottom of the course calendar, I've got my week-to-week schedule. And in yellow, you'll see my student hours. So that's time that I've dedicated to you. Now, I do appreciate a heads up if you are going to attend student hours, because I do have a lot of stuff to do, and I have a lot of other students that might be coming in. And if my student hour gets full, I want to be able to tell you I'm not able to meet with you. So at least a day's notice is really helpful, so that I can make sure that I'm free and that there's time for you to meet with me. But I've got them scattered throughout the days, throughout the time of day, throughout the week, to try and make it as available to you as possible. And I know some of you are looking at that saying, I work every single one of those days. And that is really the struggle about students that sign up for night classes. It's really hard for me to make time to meet with you in student hours. So we'll have to work out something else. We'll have to do better about communicating over email or something like that. Now, I also know that not all of you are on campus when you're free. So I'm happy to meet in the STEM Center. I love meeting up there. I'm happy to meet in my office, but I'm also happy to meet on Zoom. So if you scan that QR code, it will pop up a pre-generated email that goes to me that says, Professor, I'd like to meet with you on this day at this time in this location. And I think it literally says that, so you have to go in and edit it. So I'm trying to make it as easy as possible for you to send me a reminder and set up a meeting with me. You don't even have to work up the nerves to figure out what my email is. Just scan that QR code and it pulls up my email. Deal? I think I tried it once, but if anybody wants to try it and tell me that it really works, I'd really appreciate it. My phone is preoccupied, or I'd do it myself. Student hours are for you guys, and I'm trying to dedicate as much as I can. Obviously, I really can't dedicate 10 to 5 p.m. on Fridays, but I don't teach on Fridays, which means I'm trying to be as flexible as I can be for you on Fridays. Great question. Thank you for that. Okay. Anything else?
Is the STEM Center in this building?
It is, yes. We're on the 3rd floor. The STEM Center is both the 1st floor and the 2nd floor, and they've got their own stairwell connecting them. It's kind of an awkward shape place. It's not somewhere you'd accidentally walk into, and that can make it feel intimidating. But it is meant for you. It is free for you. They want you to come in. And there's people at desks right in front of the door, so that makes it seem like it's exclusive. It is, you're a member. I always get stopped too, and they're like, you need to sign in with your S number. I'm like, I've tried. My S number doesn't work because I'm a professor. And they're like, oh, sorry. So we're in the south wing. If you go down the center wing of the building, it's at the corner of the center wing and the north wing. Actually, if you go down on this floor, there's a window that looks down over the whole STEM Center. Fun. You'll probably see Johnny. You guys don't know who Johnny is, though.
You said it's open until 9.
Mm-hmm.
Okay.
Which is really convenient for you guys in this class, because you can actually just leave class and go dedicate some time to studying in there, if you have the time. Thank you. I tried one QR code website that gave me a 30-day free QR code. And then they said, your QR code is going to be deactivated. Honestly, I didn't know you could deactivate a QR code. I thought that it was like a set of dots that makes something happen. But I was like, screw you guys. I'm pretty sure I can find a free one forever. And I did. I'm glad. Glad to hear that. Thank you. All right. One of the other expectations that I want to have for the class is giving you guys an opportunity to stand up, move around, get your blood flowing. And that's because sitting for 2 hours is not an effective way to learn. So about halfway through the class period each day, I want to give you guys that opportunity to move around. So why don't we take between 5 and 10 minutes right now, wander around, go find the STEM Center, go find some snacks over in the same area, find the bathrooms, do whatever you got to do, and then let's come back in and keep talking and wrap up our lecture period. All right? Oh, yeah, thank you. Appreciate that. Good to have you back in Congress. It's good to have you back too. Thank you. That was amazing. That's okay, I'll grab it. You can leave it. Planning on it. Yep. If I have the same schedule next spring that I had last spring, it will be the Tuesday, 5 to 7 p.m. class. Fingers crossed. But if I can't. I literally can't. You know, I get so many emails from waitlisted students. Probably a number of you are here in the class. They're like, I'm waitlisted for this class. I need to get in. It's the only time I'm working. And like, okay. I can't do anything. Nothing. Thank you. So, it always works out. Thank you. Over the summer? Okay. Well, it works out for this class. Good. Glad to hear it. Okay. Yeah. Yeah. Why don't you figure out what you think is going to work best for your learning? So, if it means trying to take it early, if it means bumping it back late, Ideally, I'd like you to take the midterm with us, but if it doesn't feel like that's gonna be possible,
Oh, nice. What would it say?
I think, you know, they say, what tips are high impact practices. Going to a conference is considered a high impact practice. So I maybe wouldn't like to reschedule if you were like going on vacation and then coming back. But for the sake of a conference, I'd be willing to negotiate a little bit. We can talk more. Thank you guys. I do. Tell them I say hi back. Are you up at West Weaver then too? He was a great student. He came back for my OCHM 2 as well. How's he doing? Did he apply to that school yet? No way. That's awesome. You gotta tell him I'm disappointed he hasn't kept me up to speed. Do you know his friend Alex? Boy, I bet if I gave you a lot of things, I'd a lot more. Just practice. You know, Alex and Kobe took my OP1 and OP2 together.
Yeah, I know that, but I've heard Kobe told me.
Never know.
Yeah,
But yeah, that's cool. Small world. Good. I'm glad you're here. And you got a long drive, huh?
Yeah.
You know, Kobe took my OCHM 1 class in a spring semester when I was teaching the 7 to 9 p.m. lecture. So he'd have to drive back up to August at 9 p.m. That was tough. You're in that lab. Do you have Sarah Moore as your instructor? Luckily, not all of the labs are going to go until 9:30. Yeah. So there will be some, but not all of them, which is. But I didn't grab it. Oh, you didn't grab it? The beers was, it was enough for it. Okay, so I got tired. But around here,
That's what I do to everyone. Like, I don't do.
Oh. Sorry.
I also kind of want to. I'll join you guys if there's any collaboration. Yeah, you be part of our table. Yeah, you be here. I started. Oh, that's right. Yeah. I love the name.
In my science.
No, yeah, like, so luckily it's a day job, so like after 5, I do go around, so I can
Yeah, I mean, she's an actor. Worked along I did hear from her today.
The second I have to start paying for my own phone is the day that I switch to the modern. I've been on my mom's phone for the last 3 ever.
But it is on the schedule.
I have a drop app.
The email today said last section schedule. To me, it's just kind of like a whatever, you know, we'll get it.
The only thing that I've seen, music programs are like,
But I actually don't know if you follow it through.
I'm just using it for work because it's stuff where it really starts to fall apart for half of the day.
Yeah. You know what, honestly, if you don't do it, just tell her, I had to pay for it. I'll even catch you up to speed. I wrote those. Yeah, so. All right, guys. So I realized that I had a different plan of how I was going to segue us through the get to know you cards, and I missed it. That's okay. And then I erased it. But I wanted to tell you guys a little bit more about myself too. In our next class period, I want to have you guys talk a little bit more about yourselves, but for right now, I'm gonna just try and soak in taking in your faces so that Wednesday I can do a better job hearing your names and matching them to your faces. So I want to tell you a little bit about myself. I erased it, unfortunately, so you'll have to imagine. You guys are welcome to call me John. You can call me professor, instructor. Doctor would be incorrect. I don't have my PhD. You could call me master, like a Jedi Knight. I do have my master's from the University of Colorado Boulder. I got that in 2021, and I applied here and got hired right after to start teaching labs. I am originally from Wisconsin, though. I grew up in a small town, big family, and I got my bachelor's in chemistry from the University of Wisconsin-Stevens Point. I started college as a business major because I didn't know that chemistry was so cool, or that I was a nerd. I thought I was going to go back home and take over my family business. So after taking a few business courses, and taking a non-science major chemistry class, I told my friends this chemistry class kind of sucks. And they were like, yeah, it's so hard. And I was like, oh, no, it's like not hard at all. I was expecting a challenge in this class. And they said, that sounds like you should go and study chemistry. So I added a chemistry minor and I took Gen Chem. And then I realized I'm not going to learn that much in business that is going to help me back home. So I'll just get a business minor and I'll do a chemistry major. And then I took a few more business classes and I said, I don't need a business minor. I'm not going to do anything with business. Starting my freshman year of college, I also started tutoring chemistry. And I realized that that was where my passion lay. I loved teaching people about chemistry. I didn't really care that much about getting into the lab and doing chemistry, but talking with people about chemistry was just so cool. So I decided as a sophomore going to a junior year of college, I wanted to become a chemistry professor. And the only way I had seen that done at my four-year institution was to get a PhD and go back to a four-year institution. So I applied to 5 graduate programs. I got rejected from 4 of them, including the U, but I got accepted to 1. And a year and a half into that PhD program, I realized what a PhD program entailed, and it's just chemistry. It's no teaching. And I didn't have the motivation to get up, to go to work, to plan my projects, to do anything that earned me my PhD, because the PhD was not what I wanted. It was the career that I wanted, that I thought the PhD opened. So I heard about students that would leave the PhD program and instead they would be given a master's degree. And with that master's, they'd get hired at the local community college to teach. So that's what I wanted to do, teach college chemistry. So I left my PhD program with a master's degree, came out here, got hired. It took me about a year before I was given a lecture class. And that was only because I rocked the boat a little bit and I said, the organic labs here suck. Didn't know I was offending some of the professors that built it. But they retired anyway, so a new wave of administration came into the chemistry department and they said, why don't you rebuild the chemistry labs while also understanding what the chemistry lectures are like. So I got to teach the OChem lectures the summer of 2022. And I will say, I have taken so many courses on being a better educator in that time. The class I teach today looks nothing like the class I taught 3 years ago, and I think it's for the best. So in that time, I have been an adjunct. I've worked as a temporary full-time employee, and last summer I got hired as a tenure-track professor here at Slick. I couldn't be happier to be here. I would encourage you all to go to a community college, except you're all here already, so good job. This is the place to be. We've got the right size class. You've got my full teaching attention focused on teaching. Sorry, my full career attention focused on teaching. I'm not splitting my time between doing research and forced to come here and teach you. I don't really care if you like chemistry that much. Like I said, I'm not that much of a chemistry guy. I just think it's super cool. I hope that you find a new perspective on chemistry this semester. I hope that you find a perspective on chemistry that changes the way you perceive the world, too. I want you to take your macro scale life and understand what's happening at a molecular level. And I hope that you enjoy coming to class, even when it's challenging, even when the semester runs long and you start to run out of fuel. I hope that you can build a community here that helps you recharge and gain some passion. And I hope that you are reminded of why you're in this class. This, I know, is not what most of you want to do. It's a stepping stone for you. So throughout the semester, I want to be that stepping stone. I want to help propel you towards your careers. So a few fun facts about me. One, I said I'm from a small town and a big family. I have more graduating classmates, excuse me, I have more siblings then I have graduating classmates. I've got 7 siblings, 6 biological, and my youngest sister is adopted. And I've got, did I say that right? 7 siblings, 6 graduating classmates. Granted, that's because I went to a small school in a neighboring town. My town actually didn't have a school. That's how small it was. So I'm used to really tight-knit community like this. Actually, this is like the size of my entire high school, not just my class. Another fun fact about me, the one that I put up here, is that I'm a lifelong learner. I think education and learning things is super fun, and I don't ever want to stop being a student. I think I'm a better instructor because I'm a student. I remember what it's like. I know what it's like to be on that end and not feel like you're getting it, to feel like you're learning a new language and to feel like it's not coming easy. I know what it's like to have to dedicate time outside of class, outside of work, and outside of living your life to do the assignments for class. So I try to be mindful of what I assign and why I assign it, only to propel you to do well in this course. 2 ways that I'm a student right now. I'm enrolled in another education course. This one is actually called Inspiring Lifelong Learners. If you guys are comfortable with it, I'll be given assignments throughout the semester that I need to implement in my classrooms, and I'd love to bring those assignments here with you. My first assignment is being passionate. Would you guys give me a grade on that? Thumbs up. Great. I'm going to tell my teacher. Thank you. But I'm excited to learn more about being an educator and to apply it here in the moment with you guys because, like I said, my class doesn't look the same like it did 3 years ago, and I hope it doesn't look the same 3 years from now. I hope I'm able to continue evolving this classroom. The other way that I'm a student is I'm a student of the Arabic language. My partner is Arab, that's his native language, and I want to be able to speak his native language too. And I feel like a baby learning how to speak, literally making sounds. I had to learn the alphabet, and they write the opposite direction. They have a totally different script. Nothing made me feel more like an infant than starting a new language. And organic chemistry is nothing if not a new language. You're going to be learning your ABCs. You're going to be learning how to write and speak and talk and read. And it can be a challenge, and I know what that's like. So I'm going to try and teach from the perspective of training you on that language. I'm actually enrolled in a course this fall, Arabic 1010, to get some formal education on Arabic. Duolingo is just not cutting it. It's not fair, you know. I just have to do 5 things and it checks me off for the day and I don't put any effort in. So I did put some money into this. I got to buy my textbooks. I'm going to have to spend time at home on the weekends doing my homework. But I'm excited because it's fun to learn. It's fun to stretch yourself and challenge yourself. And I know that you guys have a lot on the line with this class and with this learning experience. So I'm trying to give you guys the best experience you can get. Best bang for your buck. So I'm excited. I hope you guys will find some excitement to this semester. I hope that we can make this a good semester for us all learning. Now, before I send you home, I do want to talk to you about the fundamental forces. This is the underlying foundation of all of science. There are 4 of them. The weakest one is arguably not actually a force. Does anybody know what it is? I didn't read your lips that way. It's gravity. Now, gravity is considered maybe not a true force because Einstein's theory of relativity says that gravity is the manifestation of warped space-time. You are traveling in a straight line. You're just traveling in a straight line, that goes through narrower and narrower or warped space-time. So it feels like you're being pulled down towards something. It feels like the Earth is being pulled towards the sun. So it's considered a force. They've yet to prove it. And I think that's okay. I want to talk to you guys about what experiences gravity. You're on it. Say it again. Things with mass experience gravity. So can we name some of the things with mass? Give me something.
The fundamental particles like protons, electrons.
You guys watched my YouTube channel already. You've seen this. That's true. Protons, neutrons, electrons. Those all experience gravity because they all have mass. And we could scale up from that, right? We could say atoms, which are nuclei with protons and neutrons surrounded by electron shells of electrons. We could say molecules, which are composed of many atoms. We could say organisms, which are composed of many molecules. We could say planets, which are composed of stuff. So, things with mass, and it starts there. Is that the only thing that experiences gravity? Light experiences gravity, and light does not have mass. Throughout the semester, we're going to represent light, not gravity, sorry, with this abbreviation h nu, which is part of that equation you learned in Gen Chem on how to calculate the energy of light, Planck's constant and frequency nu. But we know that light experiences gravity. Astronomers will tell you that gravitationally dense galaxies warp light. I don't know if you guys are astronomy nerds, but it always pops up on my TikTok with that lensing effect that some galaxies have on distant stars. Black holes, we know, suck in light. And the only reason that we can see a black hole is because that light is being ripped around the black hole and then shot past it. So light experiences gravity as well. Cool. All right. The next force that I want to talk to you about is actually the electromagnetic force, electromagnetism. And this is one that I'm going to have a lot to say about. Electromagnetism, obviously, is comprised of two parts. There's the electric part of electromagnetism, and there's the magnetic part of electromagnetism. Are those different forces? No. They're different manifestations of the same force. They interact with each other. Veritasium has a very interesting video that says when you plug in an electric cord to turn on something, you're not necessarily waiting for the electric current to move through the field. You're waiting for the electric field to generate in the material. And he has some pretty interesting evidence for that. So if you're curious about how electricity and electric fields differ, Veritasium is a great resource for you. So I want to talk first about this electro part. This generally has to do with our electrons and protons. So let's consider a few different scenarios where our charged particles are interacting with each other. We know that when electrons are nearby each other, they repel. When electrons are nearby protons, they attract. And when protons are nearby protons, they repel. This idea of attraction and repulsion leads me to my biggest disappointment of today, and I am going to blame it on being sick. I didn't bring my demonstration prop. I've got little magnets that I like to pass around. You guys remember from Gen Chem when I passed them around? I like to have you guys feel magnets while I'm talking about this. So I'm going to bring them next week, and I'm going to make you feel them, because this is the analogy for chemistry. What is that? That's literally just all of your fundamental particles that make up all of the matter, that make up all of the molecules that we're going to study today, this semester. So everything in chemistry is governed by that electromagnetic force. All of your reactions in chemistry are governed by the electromagnetic force. And this idea of attraction and repulsion, I'm thinking that it will remind you of magnets. When you get magnets lined up next to each other, you've got a couple of different situations. You can have like ends of a magnet near each other and you'll feel repulsion, or you can have like ends of a magnet, opposite ends of a magnet next to each other and you'll feel attraction. So charged particles are just magnets. They're doing the exact same attraction and repulsion thing. In fact, what's this made up of? My bar magnet.
I'm assuming conductive metal.
Maybe not conductive, ferromagnetic. So something like iron, maybe nickel. I think cobalt is in that too. Copper is very conductive, but not inherently magnetic, right? You got something like iron. Okay, is iron made up of magnets? No, iron is made up of protons and neutrons and electrons. And specifically, what makes this magnetic attraction here is when you have a charged particle like an electron that starts spinning. When that charged particle spins, it creates an electric field. So you get the north end and the south end. Now, I may be oversimplifying this, but this is why I like to say it makes sense that electrons pair. Because you'll get one electron that spins one direction, and you'll get a second electron that spins in opposite direction and creates a magnetic field that moves in an opposite way and has an opposite orientation. North attracts south, south attracts north. Yes, electrons have the same charge, so they repel each other, but they are magnets when they spin. So they attract each other if they spin oppositely. There's another cool thing about electromagnetism, and I'm going to save this spot for later, so I'm going to come back over here to finish electromagnetism. Actually, I might not need it. You can use magnetic fields to move electrons. Does anybody charge their phone with a wireless charger? It's not as many as I thought. I do. A lot of you have probably seen those wireless chargers. And you feel that magnetic click, right? The magnetic field that's interacting between your phone and the charger is inducing a current with your electrons. The magnetic field is making the electrons move. But how do you make a magnetic field? You need to move electrons. So you've got electricity pumping into your charger, or you've got a battery, and that creates a magnetic field, and that magnetic field interacts with the electrons in your battery and your phone and charges it. Your car does something similar. Your engine runs and turns an alternator. That alternator runs electricity around a copper wire, which creates a magnetic field which charges the electrons in your battery, give or take. So, this idea of electromagnetism, they are not different things, despite how distinct they feel. They are two sides of the same coin. They are interdependent on each other. And there's actually a force carrier. The electromagnetic force carrier. Can anybody tell me what it is? A wave of what in the ocean? Electromagnetic wave? Can you give that a name? Come on. Electromagnetic waves, anybody? Propagating electromagnetic force, radiating it?
Is it just electricity?
Not electricity, no. Radiation, we would say electromagnetic radiation is the force carrier, or is the force moving, but what is the name we give to it? Sorry? Mm-mm. Light. Yeah, I was trying to give you a hint by blocking the light from my face. Light is the electromagnetic force carrier. So remember earlier, all those things that interact with electromagnetism also interact with light. For instance, the light that's being produced up here happens because electricity is being pumped into something. Electrons are being shot up in that something and then falling down and releasing a photon of light as they fall. And that light is just propagating electromagnetic radiation, and then it hits my eyeball and makes the electrons in the molecules in my eye move up in energy, and then they fall down and give an electric current that then gets processed by my brain. And you all probably know more about that part than I do. So light is the electromagnetic force carrier. It contains two directions. It contains the magnetic field, often represented by a big B there with a vector arrow on top. And perpendicular to that, and I know it doesn't look very perpendicular, but it's really hard to draw it, is the electric field. So the light that's coming into my eye right now is interacting with the electrons via the electric field. But there is also the magnetic field that is there. They are propagated at the same time, but they're propagated perpendicularly to each other. And this is the idea that if you have an electric field, you have a magnetic field. If you have a magnetic field, you have an electric field. So we're going to use some techniques this semester where we use a magnetic field to pull charged particles and change their direction, because we can take advantage of charged particles interacting with magnetic fields. We're also going to take advantage of how specific protons give off wavelengths of light. We're used to electrons dealing with light. We're going to take advantage of protons. It's going to be very useful. And lastly, we're going to take advantage of how specific wavelengths of light interact with electrons in specific environments. Electrons that make up specific bonds between specific atoms with a specific number of bonding characters, single, double, triple. They interact with specific wavelengths to specific amounts. And so we can analyze what's going on within a molecule by looking at how light interacts with it and how light is produced by it. And it's all basically just magnets. So if you think chemistry is complicated, then your chemistry professor never told you that you're just dealing with a bunch of different, specific, cool magnets. Electrons are magnets, atoms are magnets, molecules are magnets. You are magnets. They're just very, very weak magnets. That's okay. Okay. The other forces. After gravity and electromagnetism, let's talk about the strong nuclear force. Now, as you can imagine, the strong nuclear force exists in the nucleus. This strong nuclear force is responsible for overcoming a proton-proton repulsion. So if we look inside of our nucleus, there's a charged particle plus, there's a charged particle plus and minus. There's 6 pluses. There's 6 zeros. So I'm showing 6 protons, 6 neutrons. Can you tell me what this nucleus is called? I know it's a weird way to see it, but what is that nucleus called? Yeah,
It's a hydrogen ion,
technically it would be a hydrogen ion.
right?
It's also what? A proton. That's what's weird about hydrogen ions. They are the fundamental particle proton. That's kind of weird. More specifically than just hydrogen, this is H1. What is this nucleus called? Hydrogen. Because it has 1 proton. But specifically, it has a mass of 2. This is H2. What is the relationship between H1 and H2? Isotopes. These are called isotopes because they have the same number of protons, they're the same element, they have a different number of neutrons, they have a different mass. So these are our isotopes. So can you tell me what isotope of what element I have here with 6 positive charges, 6 neutral charges, 6 protons, 6 neutrons? Carbon, what isotope? Carbon 12. This is the most abundant isotope of carbon, and carbon is the base element of organic chemistry. So we're going to be dealing a lot with carbon. We're also going to be looking at oxygen a lot, which has a mass of 16 often. We're going to deal with nitrogen a lot, which has a mass of 14 often. So inside of each of those nuclei, protons are being shoved next to each other. Like these 2 protons right here, which need the strong force to overcome their electromagnetic repulsion. All right, I told you there was one last one. I ran out of space. The last force is called the weak nuclear force, and this, I think, is kind of the hardest to understand. But I'll show you where the weak nuclear force comes into play. Imagine that you have an atom of carbon-14. Carbon-14 is made up of 6 protons, because it's carbon, and 8 neutrons, because it has a mass of 14. Carbon-14 is useful for radioactive dating because carbon-14 is radioactive. Carbon-14 decays into nitrogen-14. What conversion is going on there? Well, it's a different element, which means the number of protons has changed. I went from 6 protons to 7. And the mass is the same, which means the number of neutrons now has to change as well. The neutrons drop down to 7 as well. A neutron is being converted into a proton. And this change within the nucleus of a neutron being converted into a proton gives off the weak force. It's hardly detectable. There's not a lot of energy in it, but protons and neutrons don't have the exact same mass, and so we can kind of explain it by the loss of that force. E equals mc squared. Some energy is lost here, the weak force. That's not a perfectly balanced equation because I have increased the number of positive charges without changing the amount of negative charges. So the emission of a beta particle, an electron essentially, would also probably be seen in there. But that's where the weak force comes into play. Don't really understand it, doesn't apply to our chemistry. All of the chemistry that we're going to be dealing with today, this semester, it's all electromagnetism. Everything is just magnets. And so I'm going to try to use that analogy. When things get muddy and confusing, we're going to try to simplify it down to saying, this is this type of magnet, this is that kind of magnet. All right? Thank you guys for your attention today. Thanks for coming. I'm excited for this semester. I'll see you all Wednesday, no class on Monday. Have a good weekend.